Welcome, ladies and gentlemen. So what I'd like to do is show you how to write an equation in slope-intercept form when given 2 points. So basically, if we're going to write an equation in slope-intercept form, we're going to have it in this format. And we know that we need to identify what the slope is and as well as what the y-intercept is. Now, typically, there's a couple different ways to do this. We can use point-slope form as well as using slope-intercept form. So I'm going to do both forms in this case. But for this example, there's something that's very, very important that I automatically notice. I notice that my x-coordinate is 0 and my y-coordinate is 7. This represents the y-intercept because if you were to graph that point, 0, here's your x-axis, here's your y-axis. If that's x and that's y, 0, x is 0, and y is 7. 1, 2, 3, 4, 5, 6, 7. So that point represents the y-intercept. So that's good. Now all I need to do is figure out what m is, which is my slope. So there's a couple different ways to do this. One of the best ways, though, to get started, which you want to make sure you know, is using the slope formula, which is y2 over y1 over x2 over x1. Because remember, what does slope represent? Slope represents the change in the y-coordinates over the change in the x-coordinates. What does change mean? Change means the difference. You're going to be subtracting. So basically, I'm going to be subtracting the 2 y-coordinates and subtracting the 2 x-coordinates of my 2 points to be able to find the rate of change, or the slope. So you have an x and a y, as well as you have another point, x and y. So if I said, what's the x-coordinate, you'd have an issue because there's 2 x-coordinates. There's 0 and there's 3. So the way to differentiate between the 2 x-coordinates and the 2 y-coordinates, we give them subscripts, x1, y1, x2, y2. So now if I say, hey, what is x1? You'd say 0. What is x2? You would say 3. So now, basically, what I've done is I've labeled these. Now I'm simply just going to plug them in to find my slope. So in doing that, I have m equals y2, which is 5, minus y1, which is 7, divided by x2, which is 3, and x1, which is 0. OK, now you just simplify the numerator and the denominator. So what I have is 5 minus 7 is equal to negative 2. 3 minus 0 is equal to 3. So negative 2 over negative 3 equals a negative 2/3. You can write the negative sign in front. You don't need to write it in the numerator or the denominator. You can just write it in front because the negative could go either or. So therefore, now I know what my slope is. And I determined what my y-intercept is, which would just be 7. So therefore, I can write the equation on my line as y equals negative 2/3 x plus a positive 7, or plus 7. OK, there you go. As simple as that. So now in our next example here, a lot of times when we're thinking about this, whenever you have 2 points, again, you could use the slope formula. But if you don't remember the slope formula, hopefully you remember the point-slope form. And remember, point-slope form we can write as y minus y1 is equal to m times x minus x1. Where, remember, x and y represent any point on the graph, and y1 and x1 represent also any point on the graph. Well, we have 2 points. So what I can simply do is say, all right, well, I'll have these be xy, and I'll have this one be x1, y1. Because now we're given 2 different points. So if I plug those points in, I can determine what my slope is. And again, if you just look at this, if you subdivided y minus y1 over y minus y1, oops, I'm sorry. Other way around. If you divided x minus x1 and x minus x1, you would have m is equal to y minus y1 over x minus x1, which is really the same thing here. Remember, the 2 is just a way to identify this. So I could use y2 and x2 instead of y and x, but it's just ways for us to differentiate between the x's and the y's. So it really doesn't mean anything more than different ways to label the x and y's. So let's go ahead and plug in our information. So for y, I have 3 minus y1, which is going to be 9, is equal to, I don't know what m is yet, and then times negative 1 minus 2. OK, so now we just go ahead and simplify. So 3 minus 9 is going to be negative 6 equals m times negative 1 minus 2 is going to equal a negative 3. So now to solve for m, I see that m is being multiplied by negative 3. So I can divide by negative 3 on both sides. and I get positive 2 equals m. Okay? So now this can be very helpful. But again, we know what m is. Cool. So we found m, our slope. But now we need to find the y-intercept. So I could go back to my point-slope form again. And now you can pick any one of these points. But since I already labeled x1, y1, since I labeled the point 2,9 as x1, y1, that's what I'm going to plug in for x1, y1. And I'm going to leave y and x open because I want those to represent any points on the equation of the line. So what I'll do is I'll do y minus y1, which is 9, is equal to, now I know what m is, which is 2, and then times x minus x1, which is 2. So then I pretty much apply distributive property. I'm going to have to do my problem back over here. And what I obtain is y minus 9 is equal to 2x minus 4. Then to solve for y, I add 9 to both sides, and I obtain y equals 2x plus 5. OK? So this would be the case of using point-slope form. All right? And I think a lot of times point-slope form works to do the slope, but I don't really think it's the most efficient. I think if you can remember the slope-intercept form, that's the most efficient way. And then use point-slope form once you know the slope and a point, then to plug it in. So let's go and do that for this one. Automatically, when I know I have 2 points, the first thing we're going to want to do is label them. X, y. That marker kind of stinks. X, y, x, y. And then to differentiate 2 points, let's do x1, y1, x2, y2. Then I'll use slope formula. So I'll do m. Man, my markers, I'm losing all my markers. M is equal to y2 minus a y1. Notice how I use parentheses. A lot of students will see this and say, oh, y2 minus y1. Well, that's negative, so they do negative 1 minus 2. No, it's negative 1. It's y1 minus y2. Negative 1 is y2. Negative 2 is y1. Just be very careful with that. And then I'll do 2 minus a negative 3, or x2 minus x1. So again, the reason why that's so important is because when you have minus a negative, that's a double negative. So it's the same as adding. So therefore, when I go ahead and simplify, I basically have negative 2 plus 2, which is 1, and then 2 plus 3, which is 5. OK? So now I have my slope. I also have a point. So what I'm going to do is, again, use my point-slope form and just say y minus y1 equals m times x minus x1. Then I'm going to say, all right, well, I'm going to have these two as my x1 and my y1. So I'm going to replace my y1 with negative 2. So it'd be y minus a negative 2 is equal to m. I know now m is 1/5. And that's going to be times x minus x1, which is negative 3. OK, so now we're just going to simplify. Y minus a negative 2 is y plus 2. Apply distributive property here. What I obtain is x over 5. Oh, I'm sorry, let's write that in front. What I obtain is 1/5 x, and then that becomes a positive 3 plus 3/5. Then I subtract a 2. Subtract a 2, and now I need to subtract 3/5 minus 2. Well, how do we do that? You create your 2 into a fraction. Whenever you're subtracting a fraction from another fraction, you got to get common denominators. So I have to multiply by 5 over 5. So therefore, I have 3/5 minus 10 over 5. Now you have 2 fractions with the same denominator. You can just subtract the numerators, which is going to be a negative 7/5. So now when I go ahead and combine, I get a final answer of y equals 1/5 x minus 7/5. And that's going to be my final answer. On the next example, negative 3, negative 2. Oh, OK. I switched that around. Cool. OK. Now in the last example, again, let's just go ahead and figure out what the slope is. So first thing I want to do is label xy, xy, 1, 1, 2, 2. OK, use slope formula. When using slope formula, I have negative 4 minus 2 over 3 minus negative 1. OK, So negative 4 minus 2 is going to give me a, let's write this down below. Negative 4 minus 2 is going to give me a negative 6. And 3 minus a negative, that's a double negative, which is going to give me 4. So negative 6 over 4, that's going to be reduced down to a negative 3/2. So that is my slope. Now, I could go back and use point slope form. I also could go and say, all right, well, you know what? I want to write my equation in y equals mx plus b format. Well, if I want to write it in that format, which I've done for all these problems, and I know what my slope is, the only thing I really need to figure out is what is my y-intercept. So yes, you could use slope-intercept form, which is an awesome way to do that. The other way to do that is to say, well, if I need to find b, I can find b if I can know what an x and a y are. Well, I actually have 2 points I could plug in for x and for y. Right? I have these 2 points that I can solve in for x and y. So what you could do is to say, well, I'm going to say x1, y1. I'm going to replace those with x and y, or x2, y2. It doesn't really matter. Let's go ahead and use x1, y1, though. So if I plug those in, I get 2 equals negative 3/2 times x, which would be negative 1, and then plus b. So now you can see I know what my slope is. All I need to do is find my b. So I plug in x and y, one of my points. It doesn't matter which one. Plug them in. Now solve for b. So I have 2 equals, that becomes a positive 3/2 plus b. Now I got to solve for b, so I got to subtract 3/2. So now we're back up to where I was before. Now I have 2 minus 3/2. Just like I did here. Rewrite this as 1. Multiply to get common denominators. And when I do that, I get 4/2 minus 3/2, which is 1/2. So therefore, 1/2 equals b. Now I know what my y-intercept is, and I know what my slope is. So now I can just plug that into my equation and write y equals negative 3/2 x plus my y-intercept plus 1/2. So there you go, ladies and gentlemen. That is how you write the equation of a line when given 2 points. Thanks.